In today's training video, we're going to connect the optional data acquisition module to eVIEW. The data acquisition module is an accessory that allows the customer to monitor 4 external analog signals. Those analog signals can be 0 to 10 volts, 4 to 20 milliamps, thermocouples, or RTDs. eVIEW will take this external analog data and integrate it into eVIEW. So it will show it graphically, and it will also store it in timestamped spreadsheets. The data acquisition module comes in 2 parts. In the first box is the module that we actually connect the wiring to. And there are 4 channels that we monitor. So there's a connector for each channel. And they can be independent channels, so you can have voltage on one, a thermocouple on another one, current on the third, and an RTD on the fourth. Or you could have 4 thermocouples. The module comes with a special screwdriver that's used to insert the wires. They go into cage clamps, and save that screwdriver. It's very helpful in wiring the module. In the larger box, we have the hardware that holds the module. This makes our USB connection to the computer. We also have the DAC Quick Start Guide. This is what we're going to use this afternoon to help us with the installation. This gives us 6 steps that take us right from installation out of the box to running the DAC system on eVIEW. And we also have the complete eVIEW User's Manual. And the User's Manual has all the instructions for the data acquisition module. There are instructions in here on how to install it, how to configure it, and also how to use it. And we also have a USB cable that we're going to use to connect the data acquisition module to the PC. And the data acquisition module requires eVIEW 2.1 or higher. As long as your PC has got eVIEW installed, there is no need to install any more hardware for the data acquisition system. So we're going to get our quick start guide out. The first thing we need to do is confirm that we have eVIEW 2.10 or greater. In our particular installation, we have eVIEW 2.11. The next thing we need to do is connect a ground wire to the chassis. And on the back of the chassis, there's a connection. It is required for safety reasons and also for noise immunity that we connect a ground wire to that point. And this should go directly to a solid earth ground. And the next thing we need to do, step 3, is to connect the sensor wiring to the terminal blocks. In our case, we're going to be monitoring a thermocouple. And different signals connect to different terminals in the terminal block. If we look at the chart on the Quick Start Guide, under voltage and thermocouples, we see that the high signal from the thermocouple connects to terminal 4, and the low signal from the thermocouple connects to terminal 5. So we connect the wires to the terminal block. The next step is that we couple the main module to the outer chassis. So this is our main module where all our wiring connections are going to be made. And this is the chassis that's going to connect to our PC. And you can see there is a connector on both of these modules, and when we assemble them, we just have to keep in mind that the connectors have to mate with each other. Now we're going to take our terminal block that's already got our wires in it. We're going to plug that in. Now the last connection we have to make is the USB connection between the data acquisition module and the PC. So you can see in the back of the data acquisition module there's a port. It's actually got a security screw that we can tighten down to make sure that that stays put. Now we connect the other end of the cable to the PC. And we see a message come up on the PC screen saying that the installation has been made, the drivers have been found. And now we are ready to run the data acquisition module from eVIEW.
The DAC module has now been connected to the PC. In this training session, we are going to configure the DAC module and take some analog readings. The first thing we do is launch eVIEW. We go to the Start menu. We click on eVIEW 2.11. eVIEW will automatically go out and find any power supplies that are connected to the PC. In our case, we have found an eViEW 8310. To configure the DAC module, we're going to go to the Tools page. We are going to click on DAC eViEW Analog Input Settings. The DAC module has got 4 channels. We configure each channel separately. So we start off with channel 0. For our application, channel 0 is connected to a Type K thermocouple, and that thermocouple is connected to the part that we are going to heat. eVIEW gives us the opportunity to define a custom user label for each channel, and this label is going to show up on the graphs and in the spreadsheets to help us identify the reading that we're looking at. So we are going to leave the CH0 because that defines the channel that it's connected to on the DAC, and we are going to add part to it, so we know that that's the part temperature. On channel 1, we have got another Type K thermocouple connected, and this thermocouple is measuring the air temperature, so we are going to label this as air. This is just the room temperature. On channel 2, we have got an analog voltage connected. It's a 0 to 10 volt signal. For analog voltages and currents, eVIEW lets us define a minimum and a maximum value. The minimum value is the value that eVIEW is going to display when the voltage is 0 volts. For our application, it's going to be 0. Maximum is the value that eVIEW will display when the voltage is 10 volts. So we're going to set that to 1000. If the voltage were 5 volts, eVIEW would display 500. And we're going to define a user label of CH2 volts to this. Then we'll know that that is the voltage signal. On channel 3, we've connected a 4 to 20 milliamp signal. And again, eVIEW lets us define the minimum. That's going to be the value that eVIEW is going to display when the current is equal to 4 milliamps. So we're going to enter 400 for that, and our maximum is going to be 2000. So for this, if the current was 10 milliamps, then eVIEW would display 1000. And we're going to define a label that says CH3 amps. The eVIEW has got 2 graphs. It's got the heat cycle graph, which is a graph of the induction heating parameters. This will include amperage, power, and frequency. We have the opportunity to take one of these analog signals and add it to that graph so you can compare it and see how it changes with the induction heating parameters. So for our application, we are going to graph the temperature of our part, which is channel 0 on the DAC. And we're going to put that on the same graph as the induction heating data. eVIEW also gives us the opportunity to save data from the data acquisition module after the eViEW shuts down. It's after you remove the electrical power from the eViEW, you can still be collecting data from the DAC. You can program a certain amount of time you want to collect DAC data after the eViEW shuts down, in minutes or in seconds. For our application, we are not going to save any data after the eViEW shuts down. The last thing we need to do in this page is to select the DAC that we want to communicate with. eVIEW allows you the ability to have multiple DACs. One instance of eVIEW can only talk to one DAC at a time. So for example, if we had two DACs hooked up right now, we just have to select which one we want to talk to. So we are going to hit the drop down box, and that tells us what's available. For every module that's available, it'll give you two names. The name that we want to select is always the one with the mod at the end. So right now we're going to select DAC1 mod 1. Now all the settings in this page are going to be remembered by eVIEW. We're not going to have to go in and change them. Once we power this down and come back tomorrow and start up again, it's going to remember all these settings. It's automatically going to find that data acquisition module without any help from the operator. So we're going to accept all these settings. We do have two pages of graphs. The process data graph is going to show us all 4 channels from the data acquisition module. So down here, the custom labels that we defined. So right now, channel 0 is the part that we're going to heat. This thermocouple is attached to the part. Right now, it's reading 163 degrees C, and we have been heating this part this afternoon, so it's cooling down right now, but it's still rather hot. Channel 1 is the air temperature, and that's about 23 degrees C. Channel 2 is the analog voltage, which the scaled voltage is 444. Channel 3 is the analog current, the 4 to 20 milliamp signal that we're monitoring. Right now that is 841. Now in all these graphs, we have the opportunity to turn each trace on or off. So right now, we're looking at the part temperature, which is channel 0, and that's the red trace. So it's going to be right down here. We can turn that trace off, turn it back on. We can change the color of it, and we can change the thickness of it. Now if we turn traces off, we're not actually losing any data. You can turn them off and then turn them back on again, and all the data will still be there. It's just a way for us to more clearly see what we're interested in. The other graph that eVIEW provides is the heat cycle data graph. And this graph includes the induction heating parameters. This is the coil amperage, this is the power, frequency compensation, and then one channel that we can specify. In the tools page, we specified that we wanted to see the part temperature displayed here. Now temperatures from thermocouples or RTDs will either be in degrees Celsius or degrees Fahrenheit. We can change that by going to the system configuration page and changing our temperature mode. For this demonstration, we're going to change to Fahrenheit. We go back to the process data page, we can see that our temperatures are now in Fahrenheit. So the part that we're going to heat is still cooling down. It's 290 degrees F right now. Room temperature is 74 degrees F. So right now we are going to turn on the easy heat, and we're going to watch that temperature change. Okay, so temperature is rising. That's going to be the red trace. And right now the red trace is the only one that we expect to change. The room temperature is not changing. The analog voltage, analog current signals are staying the same. So we can even turn those off if we want to. If we want to just concentrate on the temperature of the part that we are heating. And on the heat cycle data graph, we can see that the temperature of the part that we're heating is in black. So we can watch that ramp up. And we can turn off some of the other ones for now, just so we can get a good view of the part temperature and what's going on there. We can change the color of this. Okay, so right now we're hitting about 1,000 degrees. That part is getting pretty hot, so I'm going to turn off the easy heat. And we'll be able to watch that temperature cool off. And once again, we can turn the other traces back on, and we don't lose any data. Now all the data is saved in a spreadsheet. It is time stamped, so you see that the time that the sample was taken. The heat cycles are numbered, so the first time that you run a heat cycle after you turn on eVIEW, that is heat cycle number 1. And then once you turn the heat off and turn it back on, that will be heat cycle number 2. We save the frequency, the power, which for an easy heat is in watts, the amperage, the analog signal from the easy heat. This is the analog input signal that's on the back of the easy heat. This is often used for closed loop control, and this will always be captured and displayed within eVIEW. We save the tap setting for your induction heating power supply. We also capture a relative time, and this is the number of seconds since eVIEW was first launched. And this can be helpful if you want to find the time between two different events. If you find two different events in the spreadsheet and you want to know how much time elapsed between them, you can just subtract the higher relative time from the lower one, and that'll tell you how many seconds elapsed between those two events. In channel 0, channel 1, channel 2 will be the data acquisition module. And we see in those columns, when we went in and changed the custom labels for those columns, that does show up in the spreadsheet. So channel 1 also shows up as channel 1 air, channel 0 part, channel 2 volts. So you are able to correlate your custom labels back to the spreadsheet. Okay, so we were able to connect and configure a data acquisition module and take some analog readings. So this concludes that section of our training. Thank you.